Hello, I'm Frederick from edufirst.co.uk, and today we're going over Cambridge IGCSE Design and Technology 3.1 types of materials. So there are basically just two sections that you have to be aware of, which is physical properties and mechanical properties. And that you have to be aware of are simply, let me make this text bigger. Mechanical properties, electrical properties, chemical properties, thermal properties, magnetic properties, permeability, aesthetics, and tactile. So mechanical property is basically just how an object reacts with physical force. When you bend it, how does it change? And for electrical properties, it's just if it is a conductor, does it melt like a fuse when put in a live wire? And for chemical properties, it is basically just how it reacts with chemicals. Does it maybe change color like phenolphthalein, turning colorless in a acid? And thermal is pretty straightforward. It is just how it reacts with temperature, its specific heat capacity, its specific latent heat and stuff like that. And magnetic, how it reacts with magnetic fields. Could it be magnetized? If it is like iron, cobalt, nickel, then they could probably be magnetized or be possibly influenced by magnetic fields. And we call materials that contain iron ferrous. And permeability is basically the degree which liquids or gases can pass through a material, as you can hear in maybe chemistry, that diffusion occurs through a partially permeable membrane, which means it lets some stuff through, and that is what it means. And aesthetics is probably a word that you have heard of. It just means how good it looks, with factors considering such as light on how it reacts with its environment. So just how people perceive its look as good or bad, and there isn't really a say on how it is judged, but it is what it is. So tactile is just sensory, but for touch, like when you twist a knob, I not sure if you have a keyboard, which it has a tactile knob for the volume, and you can really feel that it's quite damp. And some oil, some smart razors used to create that effect. So yes, that is for physical properties. And next, it is mechanical properties. So, or rather, working properties actually. So strength. Strength is basically its ability to resist external force, which is quite straightforward. Like if it is strong, it can probably not deform with pressure. And its hardness is its ability to resist um, wear and tear. You often hear that the MacBooks are not really hard, and they call the aluminum soft. That is because it is quite easily dented or quite scratchable. Like mine, I got it for less than a day and I already got a dent in it. Like it's just not very hard. Okay, anyway, so toughness. Toughness is basically its ability to withstand blows. Like if you watch boxing, then you probably hear that someone is tough. That just means that they can withstand blows from their opponents, if that makes sense. And anyways, that is durability. I apologize for my terrible spelling, but yes, its ability to resist wear over time. Like if it is durable, you can use it for a long time without having to replace something, which is quite intuitive. And it is its elasticity, which um, basically means its ability to bend and still return to its original shape which it usually have a very high elastic limit, so it's basically won't be easily deformed with external forces or some things like that. So it just is ability to bend and return to its original shape. And we also have plasticity, which is basically the opposite of elasticity. It is the ability for an object to deform permanently, which if an object is very plastic, then it probably has a very low elastic limit. And we also have malleability. You often hear in chemistry that a material is very malleable, then just it means that it's quite able to permanently deform into thin sheets while remaining structural integrity. Like, if you hear about that, you'd often see like layers of positive cations. They would be able to slide over each other while still remaining their layered structure, and that is very malleable, basically. And you also get ductility, which just means its ability to be stretched alongside a length, and that is ductility. So these materials can be basically evaluated based on a product's needs and to choose the most appropriate material physically or working properties. Like